technology. So far, when we have simulated performances, we have simulated using a spinner. Now, what if we have a situation where someone has 200 attempts? Would you want to sit here and simulate 200 attempts on a spinner 100 times? Yes or no? I wouldn't. To me, I wouldn't want to do that at all. That would take too much time. Well, in this case, this is where technology comes into effect. Now, I know on the screen that the notes is kind of small, but it's basically word for word on the paper. So if you just look at your paper, you should be fine. So technology is a great way to speed up the process. In sports, it has been commonplace to identify certain players as being a clutch player. I believe this is a vocab word, clutch. These players have a better ability to play in high-pressure situations. For example, if you are the pitcher in a baseball game and the game's on the line, there's a runner at third, there's 2 outs, and you have to strike this guy out in order to win the game. Then if you strike him out, you're basically a clutch player. You perform better when there's more pressure on you. During the 2008-2009 regular season, Sidney Crosby took 238 shots on goal and made 22 of them. Okay, so I want to find the percent. So I'm going to do 22 divided by 238. Now, I've put up the calculators. If we can't put the calculators up where they go, we will not have access to my calculators. So far, they are locked up and they will not come out until I decide so. So, people who have a calculator of their own, what is 22 divided by 238? Zero 0.9% or 0.9. Okay, so 9%. He made 9% of his shots. Now, we're talking about hockey right here. Okay? So this is a hockey game. However, during the playoffs, he only took 79 shots and made 15 of them. So what is 15 divided by 79? 18? 18% or 0.18. Okay, so this is regular season, and this is the playoffs. The data has shown that his performance is measured by goal percentage, which would you say was better in regular season or playoffs? Which one did he perform better in? Playoffs. So it was definitely better in the playoffs than in regular season. So I'm just going to draw a quick graph. It's not going to look exactly like the ones we've talked about, but it's going to be pretty close, and it's going to be a bar graph. So let's see. 5, 10, 15, 20. My increments are going to be in increments of 0.05. So it's 0.05, 0.10, 0.15, 0.20. And so in regular season, he had 9. So I'm just going to draw a decent sized bar graph. And then in playoffs, he had about 18. And I'm not, for this graph only, this is for this case only, I'm not worried about misses. When you are drawing graphs, you will need to be able to draw both the made and missed shots or goals or points or whatever it's talking about. So, there are 2 possible explanations of why his performance improved in the playoffs. The first explanation is that he had a greater ability in the playoffs. meaning his ability increased in the playoffs. So that was option number one. The second possible explanation is that his ability stayed the same and the increased performance was due to what? What do you think I'm fixing to say? Starts with an R. Random chance. Remember, our formula is always going to be performance equals ability plus random chance. This formula is never going away. It will always be here. It is very important that you know what this formula is. Hint, hint. It is very important. Star, cross, perfect. Okay. A random number generator works like drawing numbers out of a hat. So if I had the numbers 1 through 10 in a hat, and I just start drawing numbers out and finding the probability of getting that number, that's basically what a random number generator is, but instead it's using technology. This means that the numbers will be independent. 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 Meaning, do what? Oh, sorry. Independent. Okay? If numbers are independent, it means that the likelihood of drawing a certain number does not depend on what the number was drawn previously. For instance, if I have the numbers 1 through 5, okay, and I pull in the hat and I pick out 2. In order for the numbers to be independent, I have to put the 2 back. Okay? So, if I put the 2 back, is my probability to draw a 3 going to change? Yes or no? Do I still have all 5 numbers in the hat if I put the 2 back? Yes. Okay, so that means the probability is not going to change. So it is independent. To simulate Sidney Crosby's performance, we are going to use the numbers 1 through 1,000 to represent the outcomes of a shot on goal. The numbers 1 through 90, that goes in the blank, 1 through 90, will represent making a goal. So if we get this 1 through 90, any of those numbers, he made the goal. The numbers 91, so this is a typo, that 140 should be 91, through 1,000 will represent not making a goal. So, with that being said, just pay attention. You're going to flip your page over and just pay attention to the instructions. Yes, there are a lot of instructions. There's a lot of steps. But if you look at step 1, half of them are self-explanatory. Okay, because I learned my lesson last year. I could not simplify the steps. So, I literally did it step by step. So if I'm looking at my graphing calculator, so look at the steps as I'm following along on the calculator. First step is to turn it on. Step 1 done. My calculator is on. Step 2 is to press the math button. The math button is located below the green button. Now, if you are going to have confusion on where these buttons are located, I suggest you take notes on your own. So math is located below, I believe it's alpha, the green button. I'm going to hit math. Step 3 says to scroll over to prob, PRB, but it's really PROB. It's the same thing, meaning probability. So I'm going to scroll over to prob. It's the 4th tab in the calculator. Then it says choose RANDINT parentheses. So that's number 5. So I'm going to scroll down until I get to number 5, and I'm going to hit enter. Okay? It will pop up this screen that says lower, upper, in, and paste. Your lower bound is your smallest number. What is the smallest possible number I could get? 1. So I'm putting in 1. My upper bound is my biggest possible number I could get, which is 1,000. So that's the reason why it's 1 to 1,000. Whatever your number range is what you're going to choose, 1 to 1,000. In, for now, I'm going to represent as 1. Okay? Meaning, n is the number of numbers I'm going to pick. So right now, it's just going to draw one number. Now I'm going to highlight paste, and I'm going to hit enter. Okay? So then it's going to say RANDINT, parentheses 1, which is my lower bound, 1,000 my upper bound, and how many numbers I want to draw. So I'm going to hit enter. And it gave me 287. Is 287 within my 1 to 90? Yes or no? No. So did he make the shot or miss it? He missed. Okay, so do you see how these numbers represent? If I get another number, did he make or miss? I want to try to get a make. Oh man, he's missing all of these, ain't he? Oh man, nope, 95. There it is, 13. He finally made one. 13 is between 1 and 90, correct? So that means he made that one. Okay. Let's say that we want to simulate his playoffs. Okay, so I'm going to go back to my prob, option 5, hit enter, and I want to simulate his playoffs. How many attempts did he have in the playoffs? What? I want to know the attempts, not numbers, not the numbers that are made, represent made shots. I want to know how many attempts he had in the playoffs. 79. So I'm going to type in 79 for my table, or for my number of numbers I want to draw. So I want to draw 79 times, and I'm going to hit paste. And I'm going to hit enter. You see how they put all the numbers up here? And I can't scroll over to see them all. We don't want that to happen. Okay? In order to see all of our numbers, when we get to, oh flip, I must have clicked the wrong one. Math, prob, oh, I went too far. Prob, number 5, and I got 1,079 paste. When we get to this screen right here, we want to store it in a table. So in order to store it, right now I'm on step 9. I'm going to hit the STO button. And the STO button is right here above the on. Okay, so it's this button right here. Notice how it puts a little arrow on my screen. That means store. And I want to store it in list 1. So I'm going to hit second, number 1. So it means it's going to pick 79 numbers, and it's going to store it in L1. And I'm going to hit enter. Okay, yes, it still lists the number, but now, if I look, I'm going to hit stat, enter, there are my list of numbers. Don't worry about L2. I have no clue what's in L2. I think it was the previous problems or something. Okay, but it lists all my numbers in L1. Now, to count how many attempts were successful out of 79, randomly, I'd have to sit here and count how many numbers fall between 1 and 90. Do we want to sit here and count how many numbers fall between 1 and 90? Please say no. Do you want to know an easier way to count? Please say yes. Yes, I love yes. The calculator will sort the table for you. Okay? In order to sort them, you are going to press stat, and you see how it says sort A? You're going to go to number 2 and hit enter. Now, it's asking you, what do you want to sort? Where did we put our numbers? L1. So I want to sort L1. So I have to go second and the number 1. And I'm going to hit enter. And it's done. So I got to go back to my table. Stat, edit, enter, and now they are sorted. So I'm going to scroll down and I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that means 8 out of the 79 attempts were made shots. Because the next number is 92 is outside my range, correct? So 8. Also notice, if you highlight the biggest number it could possibly be, it also tells you how many numbers are right here. We'll say L1 parenthesis 8. That's because that's the 8th number in the list. Do y'all see that? Any questions on how to use a random number generator? Yes. I will help you out as much as I can. Okay? But we're going to do some practice on this, but also this is not going to be on the test. In other words, you will not have to use a random number generator on the test. And one reason why is because I can't tell if you used it correctly or not, so you won't be tested on it. Okay, so this was how to simulate using a graphing calculator. Now, the next thing we're going to talk about is an applet. Now, the applet is just this website we're going to go to. So I am going to, I need to delete. Give me 1 second. Okay. Move this out of the way. So step 1 says to go to the website www.whfreeman, and it should be .com /SRIS. Okay? And it's going to take you to this screen. Okay? So there was a little bit of a typo. So there should be a .com right here in between the N and the slash. So it's .com /SRIS. And SRIS stands for Statistical Reasoning in Sports. So it should be freeman.com /SRIS. And that's another typo, my bad. I hand type these notes and I make mistakes, so sorry. When you get to this web page, we're talking about stats. So you're going to go to the statistical applets. That's what we need, the statistical applets. It's located on the right side that you just saw. From here, we're going to choose proportion /number of successes given ability. So this link right here, and it's going to open up a new web page. This is pretty self-explanatory, okay? Enter the athlete's ability to be successful as a decimal from 0 to 1. I don't know if you want to make a note of this, but the ability comes from regular season performance. You always base the ability off of the performance from the regular season. So what was his percentage of made goals in the regular season? What did we say? 9%. What is that as a decimal? 0.09. So I'm going to put in 0.09 in here. Enter the number of attempts. The number of attempts comes from the playoffs or the post or preseason or whatever we're looking at. So how many attempts did he have in the playoffs? Come on. How many attempts did he have in the playoffs? 79. So I'm going to type in 79. Simulate one performance based on the parameters above. So I'm going to simulate it. This means, what number is that? 8? Is that what that says? I can't read it this far, and it's not on my screen. So according to this one simulation we did, he had 8 successes, and the proportion of successes was 0.101, or 10.1%. Okay? That is representing one simulation. Now, most of our dot plots had how many simulations on them? 100. So now I want to simulate 100 performances, and I want to get the numbers of successes. Now, you could either do numbers or proportions, but for now I want to choose numbers. They're going to arrange them from smallest to largest for us, so we don't have to do that. This applet will keep track of all of your results until you hit reset. So I'm going to add more trials. And so here are all the numbers that it gives me. I'm going to move this up so maybe you can see the dot plot a little bit better. Here is the possible dot plot they gave us. This dot plot, this is pretty important because the last class kind of got a little confused about it. This dot plot shows all of the possible outcomes that could happen just by random chance. Okay, y'all understand that? This is something that just randomly happened. Given that the player's ability was 9% and he had 79 attempts in the playoffs, these are all the possible outcomes that could occur by random chance alone. Now, the question was basically, did his ability increase? And in order for us to say yes or no, we have to figure out, did his actual performance occur by random chance? So what was his number of successes in the playoffs? How many made goals did he have? 15. Okay? To me, 15 is probably somewhere way over here, because each line is 2 points. So this would be probably 14 right here, so 15 might be somewhere right through there. Did any of the simulated outcomes occur at 15 or more? No. Okay? So there was no performance that was at 15 or more, correct? So my question is, do we have convincing evidence that his ability increased? Yes or no? I really need y'all talking to me right now because this is pretty key of this chapter. No, why do you say no? You don't know? Okay, think back. This is what occurred randomly, okay? In order for us to say that his ability increased or decreased, we have to rule out random chance. Does his performance occur randomly at all in our dot plot?
Yeah.
No. Okay? Because 15's way out right here, right? That's what he performed in the playoffs. Yes or no? Yes, he performed at 15. When I asked, did 15 occur randomly? I have to ask myself, did I have a point at 15 or more? No. So that means we do have convincing evidence that his ability increased. Because 15 cannot occur randomly. We kind of getting there? It's really confusing, and I understand that. So that's the reason why I will spend the next 20 minutes on this if I have to, because this is really key. If you don't understand this dot plot right here in this chapter, then we're going to be up a creek without a paddle. Struggling to get downriver, or upriver, really. Then we in trouble. We in trouble. Okay. Are we okay with this? I have a question. I'm going to say this is 13. This is the 13th number. How many goals do you think he would have to have in order to have convincing evidence that his performance increased or his ability increased? Do what? I think I heard a whisper, but I wasn't sure what you said. How many number of successes would he have to have in order for you to think that his ability increased? Okay? So you're saying that 3, he'd have to have more than 3 in order to say, yes, his ability increased. More than 13. Okay? 13 was the biggest number that he had, right? So in order for his ability to increase, it would have to be 14 or more. Okay, but looking at this dot plot alone, can we only talk about increased ability? What else can we talk about? Decreased ability. So what would be the number of goals that he would have to perform at in order for us to believe that his ability decreased? Not so much less than 13, because all of these occurred by random. Right? In order for us to believe or have convincing evidence that his ability changed, random chance cannot occur. So what is the smallest possible number that occurred by random chance? 1. Right? So how many goals would he have to score in order for us to believe that his ability changed?
9.
Do what?
9.
Not 9.
I said 9.
None. Okay, I thought you were saying 9. I was like, not 9. None. Right? Because in order for the ability to decrease, it would have to be less than 1. Well, you can't score a negative goal, as far as I know of in hockey. I don't play hockey. Yeah, we're talking about hockey. Okay, so he would have to score 0 goals in order for us to believe that his ability decreased. Now, what's really cool about this is this app does a lot of stuff for you. For instance, it gives you what could occur randomly, but it will also count the number of dots, let's say greater than or equal to, I don't know, pick a number. 6? I'm going to type in 6 back here at my computer. Okay, I'm going to type in 6. And what's really cool is instead of you sitting here trying to count all the numbers, it'll count it for you. So I'm going to type in 6. And I'm going to press count. And look, it says 71 dots are greater than or equal to 6. So what they did was they counted these and up. So let's say our number was 15. So when I type in 15, it says 0 dots are there or equal. Now, let's say, you can also save the dot plot. So if at any point you have to print off a dot plot, it will do it for you. If I hit reset, it's going to keep my numbers up here the same, but it's going to remove the dot plot. And if I hit type in 100, well, looky here. It gave me a whole different dot plot. So every time you do this, it will not be the same. So on this dot plot, what would be the biggest number he'd have to have, or the smallest number he'd have to have in order for his ability to increase? 15. What would be the smallest one he would need to have in order for his to be decreased? 1 or 0, right? So it will regenerate a dot plot each time. So it will not be the same every time. See, this one's just a little bit different. There would be no possible way for his ability to decrease here because there is a point at 0. So even if he hits 0, his abilities still stay the same. Are we understanding the dot plot a little bit better? Okay. Are there any questions about the dot plot? Okay. Misleading graphs. Let me figure out where. Yeah. I left my iPad up here, so I need to grab it real quick. Misleading graphs. It is very important that you stay away from these features of a I cannot speak today, I'm sorry. Misleading graphs. I'm trying to get it pulled up for you. It is important not to add embellishments to your graph that could cause the information to be incorrect or make you have incorrect conclusions. For example, graphs should not violate the area principle. Goodness. I can't spell words to save my life. NCIPLE. Area principle. Meaning that the area representing each category in a graph should be in proportion of the number of observations in that category. These examples are key. You might have a test question over these 4 examples. Hint, hint. These 4 examples are key. Hint, hint. What is that? Using bars with unequal widths. Okay, for example, for regular season, I use a fat bar, and playoffs, I use a skinny bar. That's not fair. I'm going to be more proportion to regular season because to me it looks like it covers more area. Hence, why it violates the area principle. I'm going to do a little survey. Raise your hand if you like football. 1, 2, 3, 4, 5. Okay. Raise your hand if you like basketball. 1, 2, 3, 4, 5. I'm going to say 3 because I don't want them to be the same number. Okay? I'm going to draw a graph that represents 5 footballs, and I'm going to draw a graph that represents 3 basketballs. Now, do not make fun of my drawing. This is math class, not art. And yes, my footballs look weird. Okay? Oh gosh. I'm going to try to make my footballs the same size, same width, same height, same everything, even though it's not going to happen. But just keep in mind, they're supposed to be the same height, same width, same everything. Okay, there's my 5 footballs. Now I'm going to draw 3 basketballs. There again, do not make fun of my basketballs. I am going to try to make them the same width. I feel like my basketballs are definitely better than my footballs. Okay, so there are my 3 basketballs. Yes, this graph shows that 5 people like football, while 3 people like basketball. But are the different balls the same width? Say yes, because they're supposed to be. Okay. Are they the same height? Say no, because they're not supposed to be. No, because look at this football. This football is only this high. Maybe like maybe half an inch. While my basketballs are a lot taller. Y'all see how the height of them are different? That violates the area principle. Everything must be the same width, the same height. Design-wise, they all have to be the same. Including if you make the made shots purple in regular season, then what color do they have to be in playoffs? Purple. Okay? So they have to have the same color for each section. They have to have the same design for each section. All of that stuff still occurs. So that was an example of a number 2 example. This was a number 1 example. Example number 3 is to not make the charts look 3D. Meaning, for example, I'm going to try to make a pie chart that looks 3D. No, it's not going to be perfect, but like I already said, this isn't art class. I'm going to say this is 25% miss. Well, this is, oh gosh, 75% made. Okay. If you notice, I can see a lot more of the made section because it's 3D. Because I can see this part, the front of the graph, it is misconceding. It looks like there is more than 75% of my design in this pie chart that is 3D. Because you cannot see the 3D section of the mist part, it is misleading. So you cannot make your graphs 3D. The last example is making sure your percentage axis starts at 0 instead of another number. For example, let's say I had 75% made in regular season and 25% made in playoffs. I'm sorry, I don't want to use 25, I want to use 30. I want to change this to 30. So I changed that to 30. I'm going to draw a graph, and I'm going to start my axis at 25%. And it's going to be 50, 75, 100. In my regular season, I want to draw a bar that goes all the way up to 75. For playoffs, I'm going to draw it to 30. If you did not notice this graph started at 25, let's say you assumed it started at 0. You're assuming. Yes, I told you it started at 25, but we're assuming it starts at 0. Does it look like they made many shots in the playoffs? No, it does not. Okay, it looks like they made maybe 5 to 10% of their shots, but in actuality, they made 30. So this is the reason why you do not start your axis off at 0 or another number besides 0. It must be 0. Even though it is fun to use pictures or in a graph, the bar charts, all of the bar charts, the images, the 3D charts, they all violate the area principle. Keep your charts simple so they can accomplish their purpose, which is accurately, I can spell this, ACCURATELY, accurately displaying an athlete's, and I'm pretty sure I just misspelled that. Yeah, I did. Performance. That is the whole purpose of drawing a graph, is to accurately display an athlete's performance. Are there any questions about the misleading graphs?